Well, hello. Welcome to our talk from Spring Native to Spring Boot 3. My name is Moritz Halbritter. I'm here with Sébastien from the framework team, but maybe Sébastien, could you introduce yourself, please?
Yeah, sure. I'm Sébastien Deleuze. I'm a core committer in the Spring Framework team. I have also co-founded the Spring Native experimental project. And you may know me by my work on the Kotlin support, for example, as well. And I'm also working on the web support on framework side.
Cool. Thank you very much, Sébastien. So you may not know me because I'm quite new in the Spring Boot team. I started in February in the Spring Boot team, and I spent the good day of the last year working on native support for Spring Boot. So Sébastien, as you mentioned, is from Spring Framework. I'm from Spring Boot. So we're doing a joint talk here to give you the goodness of all the native image, what is in Spring Boot 3 and Spring Framework 6. So let's first motivate the whole topic. So why would we compile to native? What does this bring us? So it has quite some advantages. So for example, we have an instant startup time. So instead of bringing the JVM up and let the JVM do all the startup magic, which can take quite some time, you get essentially instant startup in native image. So it starts in milliseconds rather than in seconds, which you will see later in our demo. You also have no warm-up phase because there is no JIT compiler kicking in and recompiling stuff. It is all compiled because it is compiled ahead of time. You get peak performance immediately. You also get a lower resource usage. So the memory footprint of the native image is smaller because there is no JVM overhead. The JVM needs to track JIT compiling and other stuff, which the native image does not do. So you get lower footprint, which means you can put more stuff on your service essentially. You also get a reduced attack surface because the way native image works is it does a closed world analysis, which means it starts from a point, your main method normally, and then it looks what is actually used, and it does not put all in there, but everything which can be reached from there. And this means your world is smaller. There is less code than in a JVM, in a jar, which means there is less attack surface. And another advantage is you need to enable reflection explicitly. So you can't do reflection on any types, only on these who are enabled, which further reduces the attack surface. And then on a last advantage is you get smaller images because the native image, it does not need to include a JVM, and the native image is usually smaller. It's machine code and your code, and it's the containers are smaller, which Sébastien is going to show a slide afterwards.
Thanks, Moritz. So we are now going to talk about the high-level use cases for native image because it's not always easy to understand why some people should choose the JVM, why should they switch to native. And it's obviously up to you, but we can already identify some recommended use cases. So I usually see people running their application on instances with low memory and low CPU. So for example, one virtual CPU and less than 1 GB of memory. For that use case, native is highly recommended because the JVM typically need more resources to be fully optimized. If you want to run your function as a service, native is a no-brainer because of the instant startup. And we typically begin to see some cloud provider providing scale to zero instances for regular application. Or if you are using a Kubernetes platform like Knative, for example, that's typically how this is used. And here again, for scale to zero, native is highly recommended. If you want to use microservices, if you want to deploy back offices that are not used all of the time, if you want to deploy container to a Kubernetes platform, or if you just plan to distribute your product as a container, you should try and assess if native is a good fit for you or not. It really depends. And there are other use cases where the JVM is likely better and you should typically continue to use it. So if you have very frequent deployments, native long build time could be a blocking point. If you have high traffic website, if you need agent-based observability, or if you have a big monolithic application that can run on huge memory and CPU, typically JVM may be a better fit for that. Next slide, please. And a little bit of history. last year, we launched Spring Native Beta. That was announced by the Whole Spring team. A lot of people have been involved into that, and the community feedback has been huge. But today, we would like to announce the next step of that journey. Next slide, please.
Yeah, the next step of this journey is Spring Boot introduces official support for compiling applications to native executables.
Yeah, and it really supersedes Spring Native. So if you are a Spring Native user, leveraging Spring Native to get native support on top of on Spring Boot 2, we really advise you to upgrade to Spring Boot 3, which provide a much better native support out of the box. And really, all Spring Native users should migrate to Spring Boot 3 today in order to benefit of the native support. Next slide, please.
Okay, so I'm going to show you how to get started with our native support. Let's take a look at our favorite website of the internet, the Spring Initializer, where you can bootstrap your Spring Boot application. And we added a new dependency, which is called GraalVM native support. And you need to put that in, and then you can, like always, click the generate button and open it in your favorite IDE. I already did that. And let's take a look what has been generated in there. So we have a help file which has a new section called GraalVM native support. And here is my browser view acting up. Okay, it's working. So there is GraalVM native support in there, which is a completely new section. And here you can see you have two options to build it, either with native build packs, and I'm going to talk about it later, or with the native build tools, which I'm going to use. And what I will do now is I kick off the compilation in the background because it takes some time. I'll show you the application, and then we can start the application. So this is how you compile it. What you need in your terminal is a GraalVM installation. So what I use is SDKman, which manages my Java installations, and I use the native image kit from Liberica, which is a GraalVM installation. So let's activate it in the shell and then paste our command, GraalVM native compile, and let it run in the background, and it takes some time. I'm going to show you what are the key points you need to put in your Grail file to get that working. It works with Maven too, so it's not only a Grail. The first thing you will notice if you take a look at the plugins block is that there is the GraalVM native build tools in there. This thing here is responsible for compiling your code via native image into a platform executable. And this needs to be applied because the Gradle Spring Boot plugin then reacts to that and activates more stuff in the background to get all this working. If you take a look at the dependencies, for example, there is no special dependency for native support. It's all baked into the framework in Spring Framework 6 and Spring Boot 3. It's all there. That's what we mean by production support. It's baked in and it works without any dependencies. What I created is a small controller. This controller has a logger. This controller has a small say hello method, which takes a path variable. Then it invokes the logger and it returns a DTO with hello and then the name the user gave. And if you take a look at the DTO, it's a record. We can now use records because we are based on Java 17. So Spring Boot 3 and Spring Framework 6 has a Java 17 baseline. So you can use records as DTOs. And then it just returns this. So it's still compiling. You see it took 1 minute and 41 seconds to compile this thing. And now you can run the native image. It's located in native image, native compiled SpringOne demo. And when you start it up, you can see started SpringOne demo application in very few seconds. So it's 55 milliseconds, which is a lot less than you would start on JVM. And to prove that this stuff is really working, I created a small HTTP file, which is essentially curly in IntelliJ. And when you execute it, you see greeting, hello Moritz. Okay, it returns my name, and you see that it has really been invoked. If you take a look at what this is with the file utility, it tells you it's a 64-bit executable for ARM64 because this is an M1 Mac. You get ARM64 executable binary, which you can execute, and you don't need a JVM to do that. Okay, back to Sébastien.
Yeah, thanks, Moritz. So we have seen how to create a new project, but you can also, and I think this was one of the key point of our native support, you can migrate existing application to native. So here we are going to migrate Pet Clinic from Spring Boot 2.7 to Spring Boot 3 with native support. Next slide, please. So the first thing you are going to do is migrate to Java 17. I think the migration experience is pretty smooth. No big change. Maybe you need to refine some XML dependencies, but nothing too major for most application, I think. You obviously need to change the Spring Boot starter parent version. Here we are going to use Spring Boot 3.0. A bigger step in terms of migration is migrating to Jakarta EE, because Spring Framework 6 and Spring Boot 3 migrate from Java EE and the Java X package to Jakarta EE and the Jakarta package. And so here for the Pet Clinic application, which is pretty simple one, I basically replace Java X by Jakarta. Maybe a little bit more involved. You need to check that your Java EE dependencies are supporting Jakarta EE, etc. We did a lot of work in Spring Boot to make that migration experience smooth, but obviously that can't cover everything, so you need to check for your scope. But here for the validation part, that was pretty smooth. Next slide, please. Okay, so you also need to enable the native Maven plugin. Like what was shown by Moritz previously in Gradle, we are using the native plugin from the native build tools as basically an enabler for the various native behavior that will be applied. And that's basically the main signal you will have, because the rest of the native support is basically baked in Spring Framework, Spring Data, Spring Boot. Next slide, please. We expect you to do very few changes on your code, but native need to be more explicit in terms of reflection, resources, proxies, etc. And we put a lot of energy in Spring Framework 6 and Spring Boot 3 to build an engine that can infer this configuration. So it is generated automatically, and we don't have to write thousands and thousands of lines of configuration for the native image compiler. But we may miss a few ones, or by design, you need to explicitly configure what is specific to your application. So here, for example, we are using the @import runtime annotation that gives you basically an entry point where you can use the runtime ints API that will allow you to register ints for resources, reflection, proxies. And here for this application, we just have to register a custom message resource bundle, and that's all. Next slide, please. Another thing you will typically need to customize is when you are using reflection-based serialization inside the body of your methods with types that are not exposed on your controller methods, for example. So here, the two common use cases we have is with an HTTP client, like web client or REST templates, or if you are using, like in Pet Clinic, some Spring MVC views. Those types won't be exposed on the interfaces of the bins. And so you will need to specify the types that you need to serialize with reflection-based system like Jackson, XML, JAXB serialization, etc. with @register reflection for binding, and you just specify the various types, and that's all. Next slide, please. We are not going to talk about the changes between Spring Native and Spring Boot 3 to make it clear to people used to Spring Native what is new and what changed. Okay, so Spring Boot 3 raised the minimum Java version, like we said previously, to Java 17. We are also taking advantage of the latest feature of GraalVM 22.3, so you will need to use at least GraalVM 22.3 that has been recently released. It's production-grade quality. Native image, it's still a young technology that evolves, but we in terms of quality of our support on Spring side, it's a huge improvement compared to Spring Native in terms of the level of test we have, the design, the extensibility, etc. And like showed previously, everything is built in Spring Boot, Spring Framework, and the various project. That means that if you see that a feature miss, for example, in Spring Data or Spring Security, you should just report a bug or a feature request on this project in order to enable it to be supported on native. Most of the Spring projects are supported. We have a wider library support, and that's a big point. I will give more details on that later. We are leveraging the GraalVM Reachability metadata repository in order to provide support for the various JVM libraries. A big point that you may not see, but we have put a huge amount of effort to leverage no substitution for Spring or JVM libraries code. Substitution are GraalVM native image patch to be able to replace the implementation of a method by another. It is typically used to improve the native compatibility or to improve the footprint, but it's very bad in terms of security, in terms of maintainability, because basically you don't run the same code on native than on the JVM. It's basically overriding a library method by something else. So how could you be sure that there is some security fixes taken in account? So here we are really on the same basis where we don't take any shortcuts. We just use the regular libraries code. And this is the same for the initialization of the classes. All the classes used are initialized at runtime. We do not have anymore some classes initialized explicitly at build time. That means that we have a behavior that is closer to the JVM. That means that we have resolved a lot of the compatibility issues that people experience with Spring Native, which was mixing build time initialization and runtime initialization for classes. The number one feature that was asked by Spring Native user was the lack of logback XML support. And thanks to Andy Wilkinson, it's now supported on Spring Boot 3, so you can use your logback.xml and customize the logging with that very popular file. And instead of the previous native int annotation that leads to sometimes a big amount of annotations, we now have a first-class programmatic API, runtime ints, and we also provide a pretty powerful @register reflection for binding, where you will typically register the classes that need to be serialized. Next slide, please. Okay, so this is a key change compared to Spring Native. We have been collaborating with the GraalVM team in order to introduce this GraalVM Reachability metadata repository. What that means is that Spring itself takes care of its own support. So we do a lot of things to lower the amount of reflection, make sure that most of the Spring features are compatible with GraalVM native. But when it comes to open source libraries, previously in Spring Native, we were providing some configuration for some libraries, but you quickly reach the limit. Here we have places where projects that can't provide out of the box the native support like Tomcat or Netty does. The Reachability metadata repository is a place where open source framework like us or typical users could contribute some native configuration for your favorite native libraries. That means that we have also a place where all the major framework can begin to share the native configuration. So I think it's really better better for the evolution of native. Every native configuration contributed there need to be tested, need to follow some rules, and so we have more consistency. Moritz, myself, and a few members of the Spring team have spent a lot of time contributing support for various open source libraries. And if you don't find your favorite open source library supported, you can just send a pull request to this Reachability metadata repository, and that will be automatically taken in account by Spring Boot 3.
Okay, so Sébastien talked about that we are doing a lot to, for example, minimize reflections, and we want to take a look at what exactly does Spring Boot and Spring Framework do. So the native support overview, it looks like this. It's comprised of those building blocks, and we have the components which are contributed from the GraalVM team. So there is this native image compiler. This native image compiler takes care of compiling your Java bytecode to executable bytecode, so to on your actual processor. They are the native build tools, which we already saw, the Maven and the Gradle plugin. And there is the reachability metadata about which talked about Sébastien right now. Then we have support with build packs. I'm going to talk about it in the next slide. So the build packs they transform your application from your source code into an runnable OCI image, for example, Docker image, and they are now native compatible. So if you want to get a native image in a Docker container, you can with this native build packs. Now all the infrastructure which is needed to get Spring Boot 3 and the Spring framework to work. And I start on the lower stack. So there is an AOT transformation engine in Spring Framework 6. And what this means is this minimizes reflection, because what it does is, if you take a look at the output of your build process of your app when you compile to native, you see, for example, the Spring Boot banner. And what it does is it bootstraps your application to a certain point so that we know what is in your bean context and in your application context. And then we generate source code which restores this state without using reflection. And this source code can be compiled and understood by the native image compiler to produce bytecode, which then starts even faster because it avoids reflection. There are a lot of hook points where you can hook into this AOT transformation engine, and those hook points are used by the Spring portfolio projects, for example, Spring Data or Spring Security, to implement their AOT transformations, which means they are, for example, can contribute a plugin to the transformation engine, which generates source code, which is then compiled. Or they can contribute native hints, for example. If you can't eliminate all reflection, then you can contribute hints, and those hints tell the native image, look, on this type reflection is needed, so please include it. And Spring Boot 3, it bundles all together. It has the Spring Boot plugin, which I already showed, which, for example, reacts on the presence of the native build tools, and then it starts the AOT transformation engine, and then it compiles all that to native with the help of the native build tools. And what I haven't shown in my demo, it was the native documentation. So we wrote a lot of documentation. So if you take a look at the Spring Boot reference guide, there is a new section which is called GraalVM. And there you can read pages and pages of documentation, how that works, what you do if it doesn't work, and what are the requisites. So give it a try. We put a lot of effort into the documentation. So if we take a look, what happens if you type in Gradle native compile or Maven native compile or Maven compile? This is what usually happens on the JVM. So your source code is compiled into bytecode and the resources are put into the jar. And what we do on top of that is we generate AOT sources. So AOT stands for ahead of time, so which means it's not compiled afterwards, but in the build process. And what we do is we generate those sources. So we kickstart the Spring Framework AOT transformation engine, which generates source code. And we also write classes, for example, for cglib proxies. So when you proxy a class, a cglib proxy is created, and this is captured, and then it is written to disk. So it does not need to be done on runtime, which is not supported on native image. So what we get then is your compiled sources. We don't touch them. We don't alter them. Your resources, the compiled AOT sources from Spring Boot and Spring Framework and all the portfolio projects involved, the AOT classes, for example, for proxies, and native image config. For example, if we can't eliminate all reflection, we generate config so that this reflection use case is supported. And then you can either native compile it, so you get a native binary, which you can then execute on your processor, or you can run bootjar, and this bootjar then contains an AOT optimized app, which means it does not only contain this here, but it contains all of this. And you can run it with a JVM parameter, which then uses the same code part which the native image would use when it starts up, but on the JVM, which gives you some performance benefits. So now that we know what this stuff is doing behind the covers, let's see what we have to do to deploy our application. So a good idea is to run tests before you deploy anything in production, because you don't want to test in production. And you can, of course, run the tests on the JVM. This is what's supported since ages, but there is a new feature which runs the tests in a native image. That means if you execute those commands, it compiles your application in a native image, and it compiles your test in a native image, and then runs all those tests in a native image, which means if those tests pass, you can be more confident that it does not crash at runtime if your tests are good enough. And this is the output here from the native build tools, which essentially run JUnit in the native image and then gives you a small report if everything works. So now that your tests are working, you can decide how you want to push your app into production. So there are two ways. The native build tools way, which I showed in the demo, and the build packs way, which I didn't show, but it works nonetheless. So what build packs are, they are container-based native builds, which means you have your source code, you have a Docker daemon, and then you run the thing, and it essentially builds your application inside a Docker container. It packages it into a run image, and then you can run this image. And it has support for compilation, so you give it the source code, and you get a container image with a native image in it. And this requires Docker, but no GraalVM installation. So you don't need to download GraalVM and install it. You just need Docker. And what it does, it produces a Linux container image, and there is the x64 architecture supported, and ARM support is work in progress. And here is the ticket if you want to follow it for updates. The native build tools, they started out as a collaboration between Spring and the GraalVM teams, and recently the Micronaut team has joined. It supports application compilation and testing, so this here is possible with the native build tools. It requires a local GraalVM native image compiler. See our native reference documentation, how to get one. There is, for example, the SDK command, SDK-man command. And what it does, it produces a native executable, which I showed before. And it produces the executable for the platform you have been, you built this thing on. So I built it on a macOS ARM system, so I get a macOS ARM native image. If you want a Linux x64 binary, you have to build it on a Linux x64 machine. You can even build it on Windows, and then you get an x64 executable file, which you can run on a Windows machine. So now that your application is in production, you want to see if it works. And for that, we typically use observability. And Spring Boot 3 includes a lot of observability enhancements. So the actuator is in there since a long time, and it also works on native image. So this is a curly request against a running native image, and it exposes Prometheus metrics, so you can use it as it is. What is working too is tracing. So before we had Spring Cloud Sleuth, which does the tracing part. This is now part of Spring Boot 3. So it has support, and the other portfolio projects are using the Micrometer API, the Micrometer Observation API, to produce metrics and traces. So this is now baked in, and this is working on native image too. So what you see here in the screenshot is a Wavefront application, which is a native image which reports to Wavefront, and then I took a screenshot of a distributed trace here. And the cool thing is most of the tracing is usually agent-based, so you have a JVM agent attached to your JVM, but this does not work on native image. So JVM agents don't work with a native image. And then it's nice to have support in Spring Framework and Spring Boot to get tracing working even in a native image. So let's switch over to Sébastien and talk a little bit about benchmarks.
Thanks, Moritz. So yeah, Let's have a look to the figures on Pet Clinic side. So a lot of figures on that slide, but I would like to focus on the takeaways. The first one is that the JVM is pretty slow to start application when you don't provide enough CPU and memory. And even if with a lot of CPU and memory, it takes some time. So typically, the native application will just take a few milliseconds to start, even on production, and even with low CPU and low memory. So that's an important point. The second point is that in terms of performance, JVM has a higher throughput and a lower latency compared to native. GraalVM EE is closer to the JVM on machines with more resources. On machines that are more limited, both GraalVM CE Community Edition and EE Enterprise Edition are faster than the JVM because they have more. They are consuming less resources, so that let more memory for the heap, and I think they are better designed for machine with less CPU. So you see, it really depends about what you target. But what I see usually is people trying to get cheaper cloud hosting by reducing the number of CPU, reducing the number of RAM. And if you are doing that, especially if you want to deploy a lot of instances because you have a microservices infrastructure, native could be a good fit for you. Next slide, please. Okay, now let's talk about the container size. So for Pet Clinic, we typically are using a container which is using the regular based image, and it's adding the GDK, and it's adding your application with all the dependencies, and the outcome is something that here is close to 300 megabytes in terms of size. If you are just switching to native and build a container image with, it's using by default what we call the tiny builder. So that means you have a minimal operating system that allow to create smaller container images, and also that has less surface attack in terms of security. You can see that we have 124 megabytes, which is pretty good. And you can even go the next step by enabling the UPX compression. So UPX is a native executable compression algorithm, and we have default support for that in the build packs. And here you can go as low as 51 megabytes, but be careful, the memory consumption will be higher. Startup time will remain the same, basically. No cost there, but in terms of memory consumption, it has some drawbacks, so be careful. Usually, I just deploy native container without UPX compression. Next slide, please. Yeah, and here are some figures from another application, which is a Spring Web Flux application using Netty underneath and using a few Azure libraries. You can see that the startup time, those are the figures deployed in production on low resource instances. You can see that the startup time is 100 times faster with native. And in terms of memory consumption, you can expect to have at least half of the memory consumption after startup on native. And on some application that will be more, but that really depends of your application. And that's what we have currently with Spring Boot 3.0. As Moritz is going to share, we have some upcoming improvements to reduce even more the footprint in the future. Next slide, please. Yeah, so let's talk also about the commercial support. So we have a partnership with an agreement with between VMware and Bellsoft in order to provide end-to-end support for your native application in production by leveraging the Bellsoft Liberica Native Image Kit, which is based on GraalVM Community Edition. And with Bellsoft expertise in terms of JVM and native image compiler, and the Spring expertise in terms of providing you the best support for adding support for the missing feature or fixing bug in the native support, I think we have a pretty good end-to-end native offer.
Okay, as Sébastien hinted, this is only the beginning of a journey. So there's more to come, but please don't pin us on release dates because some of this stuff is need to be explored and is involving a lot of deep work and maybe some bigger refactorings. So don't expect this in the next days. But I want to give you things to see what we are thinking about to improve this the performance and the image size even further. So the GraalVM team is working hard on further reduction on image sizes, and they want to do that by taming the build time in this initialization. And if you are interested in that, take a look at the link in the slides. Um, what we can do on Spring Framework and Spring Boot or Spring Portfolio project sites is, for example, we can think about or explore options for reflection-free property binding. So what Spring Boot is usually doing when you have stuff in your application properties, you can bind this to classes. And this is now done via reflection, but maybe we find a way to, for example, generate source code to do that without reflection. You may know those spell expressions, so the Spring expression language. Now, as it is of now, it is interpreted at runtime, but we could think about maybe, for example, generate source code or generate bytecode to do that on build time so that you don't need all the spell runtime stuff in your native image. We are already capturing zglib proxies in the build time and including them in the native image, but there are still some CG-libs artifacts in your native image, which we hopefully can remove in the future to even reduce the image size. And there are more Hibernate optimizations to come. There are quite a lot of those in the framework already, but we hope we can even put more in those so that if you're using Hibernate, and quite a lot use Hibernate in their Spring projects, you get even more performance and image size reductions. Yeah, and this concludes our talk. So I had a blast working on all that stuff and doing this presentation. So thank you for that. If you want to contact us, have questions, shoot us a message on either Twitter, and you see this handles on those handles though there, or if you don't like Twitter anymore, we are also on Mastodon. So thank you very much.
Thanks.